Good day to our lecturer and evaluators. Today, our group will be presenting our industrial visit report for our course. Our team consists of 4 members, and for this project, we conducted a site visit to Sama Mahir Sendirian Berhad, located in the industrial zone of Pasir Gudang, Johor. Today, we will walk you through the manufacturing line we observe, analyze the critical process defect, and propose an engineering solution.
Before we begin the site visit, I would like to briefly introduce Sama Mahir Sendirian Berhad. Sama Mahir Sendirian Berhad was established in 1998 with its roots dating back to 1972 when it operated under the name San Hak Seng, manufacturer Sendirian Berhad. With over 50 years of experience, the company has built a strong reputation in the casting and engineering industry. The company specializes in sand metal casting for both ferrous and non-ferrous materials, including cast iron, steel, copper, ductile iron, aluminum, and tin. In addition to its casting operations, the company also offers advanced manufacturing services such as CNC machining, laser derusting, and 3D precision printing to support various engineering and production needs. One of the company's strengths is its ability to offer complete manufacturing solutions covering pattern making, casting, machining, and other supporting processes. This enables the company to deliver quality engineering, product, and service that meet customer requirements and industry standards. Located in Masai, Johor, Sama Mahir continues to be a trusted manufacturer that emphasizes quality, reliability, and continuous improvement in its operations. Through this site visit, we had the opportunity to observe the company's manufacturing process, facilities, and engineering practices, allowing us to gain valuable insight into real-world manufacturing operations.
Our group focused specifically on the foundry section. During our visit, we observed the production of cast metal components such as pump housings and industrial brackets. Using the traditional but highly effective method of sand casting, this process is chosen because it is cost-effective for complex shapes and suitable for low to medium volume production.
Before we enter to the factory area, we need to ensure the safety of ourselves. First of all, we need to wear our jacket and make sure zip it and button our cuff. And we need to wear safety shoes. That's all.
In sand casting, there are two primary categories of raw materials. First is the casting medium itself, which is green sand. This is a precisely engineered mixture of silica sand, bentonite clay acting as a binder, and water. Second is the raw metal, which arrives as alloy ingots. These ingots are selected based on the mechanical requirements of the final product, such as high tensile strength or corrosion resistance, before being melted down in the furnace. The sand casting process we observe at Sama Mahir follows a strict sequence. First is pattern making, where a replica of the part is used to create the mold cavity. Second is mold preparation, where the green sand is heavily compact into the top and bottom half of the flask, known as the cope and drag. Third is melting and potting, where the metal is superheated to a molten state and carefully poured into the mold's gating system. Finally, after solidification, we have the shakeout stage, where the sand mold is broken apart to reveal the rough casting, followed by cleaning and machining.
For sand casting to be successful, several critical parameters must be tightly controlled. On the material side, the sand permeability and moisture content are vital. The sand must be porous enough to let gases escape, but strong enough to hold its shape. On the process side, the pouring temperature and pouring rate are crucial. If the metal is poured too cold or too slowly, it will solidify before completely filling the mold.
So over here, as you can see, this is the example of the hardening process in casting iron lap.
When we observe the casting after the shakeout process, we notice a major defect called blowholes or gas porosity. These are smooth, round holes that can appear on the surface or inside the casting. This is a serious defect because it weakens the casting by reducing the amount of solid metal that can carry the load. As a result, the part becomes less durable and may fail the quality inspection. To understand why these blowholes were happening on the Sama Mahir line, we carried out a root cause analysis. We found two main causes. First, the moisture content in the green sand was too high. When the molten metal, which is around 1000 degrees Celsius, become into contact with the dampened sand, it quickly generates a large amount of steam. Second, the mold didn't have enough venting, so the steam and trapped gas couldn't escape. Instead, they become trapped inside the molten metal, and as it solidified, they formed the blowhole we observe.
To eliminate the blowhole defect, our group proposed two targeted engineering improvements. First, Sama Mahir should implement strict moisture analyzer at the sand mixing station to ensure the water content in the green sand remains strictly between 3% to 5%. Second, we proposed a redesign of the mold gating system by adding more vent holes and risers to the top half of the mold. This will provide a direct exhaust valve for steam and gases to escape before the metal hardens. By optimizing the sand moisture content and improving mold venting, Sama Mahir can significantly reduce the occurrence of blowholes, thereby decreasing scrap rates and saving melting costs. In conclusion, observing the sand casting line in Pasir Gudang provided us with invaluable insight into how theoretical thermodynamics and material science are applied to solve real-world boundary challenges. Thank you.